All right, this next question, what is the value of x and y in each triangle below? This first triangle that we are going to use is actually, there's going to be a question like this on the test. I'm going to make it extra credit because we didn't get this far in chapter 4 yet, but it is going to be on the test, so it will be extra credit. So you might want to try to do this one and get that extra credit point. So actually I'm going to erase this blue. Here's what I want to do. I want to tell you, normally we look at this angle right here. And if this is the right angle, I know that this is the rise. If it was a slope, right, this is the rise. You've got to picture this kind of turned around like we've been doing. And this is the run. Okay, the rise and the run. We also know that slope is the same as the tangent. So if I just make this a random letter, let's call it A, I know that the tangent of 64 is going to be A over X. Okay, we could actually make it, you know what, let's actually make it a number just for fun. Let's just make it a number. Let's call it 10. And this would be the tangent of 64 is 10 over x. But that is just the blue side, or what we call the side opposite, right? Because it's a cross from 64, so we're going to call it the opposite side, over the run, which we actually call the adjacent side. Okay, so whenever we have the tangent, we always put the opposite or the rise over the adjacent or the run. Okay, but there are two other buttons on your calculator. Take a look. Here's tangent, then before tangent is cos, but we say cosine, and the actual cosine is spelled cosine. Okay, but we just call it cos on the calculator. And the one next to that is called, it looks like sin, but we call it sine. And you actually would spell that sine. Okay, and all this means if we have, what other color should we use? Green? Oh, let's do pink. I like pink. If we were going to have all of the sides of the triangle written as a fraction using different sides, it would look like this. So the tangent is the blue over the yellow. The cosine is the adjacent. The adjacent, which would be x, over the hypotenuse, which is 25. Here. So that's what we call this side is the hypotenuse. And you guys should know this because it is opposite the 90-degree angle. So if we are looking at angle 64, the angle across from it that touches the 90-degree angle is the opposite. The angle next to it that also touches the 90-degree angle is the adjacent. And the angle the side across from the 90-degree angle is always the hypotenuse. So the cosine is, the hypotenuse is the denominator, and the numerator is the adjacent side or the run side. Okay, and that's how we do that. And then the very last one is going to be the sine, and the sine, if we're looking at 64, is the opposite, is side 10 over the hypotenuse, which is 25. So we look at this again. This one is blue over pink. Okay. So the tangent is the opposite over the adjacent. That's how we set up, and we sign it all of the same. Oh, I guess I could put 64 here and 64 here. So we find these all the same. All right. the cosine is of 64 is that side, x over 25, and the sine is 10 over 25. So the cosine and the sine always have the denominator that's the hypotenuse, and the tangent is made up of the rise over the run. Okay, so I remember it as the adjacent side is the cosine, that's alphabetical order, right? And the opposite side is the sine. S and O are both the farthest in the alphabet. A and C are both the closest. And these are how you set it up. So in this case, now remember I made up this number 10. So let's not forget that that's not actually part of this problem. And let's think about what we have. If we are trying to find x, we need to use one of either the tangent, because it has yellow, or the cosine, because it has yellow, which is our x. And the other side that we actually have, the other number that we actually have is the hypotenuse. So in order to do this one, we're going to use the cosine of 64. So we know the cosine of 64 degrees is equal to x over 25. So in order to get x by itself, we just multiply both sides by 25. And that cancels out. So x is equal to, and then if we get our calculator out, we'll just put 25 times the cosine of 64. Ooh, let me make sure I'm in degrees. Oh, I'm in radians. I'm glad I checked. Degrees. Okay. And go back to the main screen. 10.959. So 10.95 if I'm rounding to. Approximately, because I'm rounding, 10.95. Okay, but again, that's going to be extra credit. But I will send out some more practice problems about using tangent or using sine and cosine to help you out. Now, what's next? Oh, look, here's another practice problem we can do. If we are looking at this angle, we have the opposite side, because it's farthest away from that angle, and our y, we're looking for the hypotenuse. So what we use when you learn this in a normal like trigonometry class, what we do is we talk about something, we use a mnemonic device, just like PEMDAS, but it is called SOHCAHTOA. And what this means is this is the hypotenuse, right? This is the opposite. Because we're looking at this angle, and this is the adjacent, this tells you what to do. This says the sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent, or the rise over the run, right? So we call the O is really the rise, and the A is really the run here, just in case that helps you with this O and this A. But really we're breaking this up into three pieces, right? The sine, cosine, and tangent. That's what this stands for, and we call it SOHCAHTOA. So in this case, what do we have? If I have this angle, 12 is the opposite, and y is the hypotenuse, so I'm going to use the sine. Okay, so the sine of 50 degrees is equal to the opposite, which is 12, that's a 5, over the hypotenuse, which is y. So when the variable's on the denominator, it makes it a little bit harder to solve. In this case, I'm gonna multiply both sides by y to get rid of the denominator. So what that looks like is now I have y times the sine of 50 is equal to 12. Now to get y by itself, I'm going to divide both sides by the sine of 50. Okay, you could find out if that's a number first, whoops, but I don't like to do that because if you put sine of 50 into the calculator last, you don't have to remember any numbers, right? Why does that keep happening? That's weird. Okay, so what we have here is y is equal to, and then 12 divided by sine of 50. So I put in 12 divided by sine of 50, just like this, and enter, approximately 15.66. So we'll change this to be approximately 15.66, whatever units that they're using there. Okay, great. I think I have 15 more minutes on the, 5 more minutes on this video, so let's try the next one. What is the length of x in each diagram? And then I think that is on, whoops, is on the next page actually. Okay, and these are all tangent because in each of these we don't have to use, well, I guess we don't have to use it for that. Let's take a look at what we're doing. This first one, since we're only doing sides, we're going to do Pythagorean theorem, which is a squared plus b squared equals c squared. The two sides, the rise and the run that touch the right angle are a and b, and this is c. So if a is x and b is 8, what does this look like? It looks like x squared plus b squared, which is really 64, is equal to c squared, which is really 225, right? 15 squared is 225, and 8 squared is 64. So now I'm going to subtract 64 from each side. So x squared is equal to 225 minus 64 is what? I'm just going to practice. Oops, clear. Okay, 161. And then to find the length of the side, this is x squared, right? I need x. I have to take the square root of both sides. So x is really equal to the square root of 161, which is approximately 12.69. Okay, now this second one, we have, this is our angle, we have the rise and the run. So we have the opposite and we have the adjacent. Remember, the rise is the opposite, the run is the adjacent. So this is tangent from our SOHCAHTOA. This is our TOA. We have the opposite and the adjacent. So we have the tangent of 11 is equal to 12 over x. So to get x by itself, we need to multiply both sides by x, and that gets rid of that. So now we have x times tangent 11 is 12. Remember, it's trickier when our denominator is the variable. Then we need to divide both sides by the tangent of 11. So we're going to do 12 divided by the tangent of 11. Which is approximately 61.73, approximately 61.73. I don't know why I keep putting equals that we're going to get a perfect answer. And then for this last one, you guys do not overthink this. Okay, you don't want to have to do a tangent when you know if this is a 90-degree angle, this is a 45-degree angle, this other angle must be 45. We call that a 45, 45, 90. If these two angles are the same, it means we have a isosceles triangle, which means that these two angles, or these two sides, are also the same. So if this side is 4, then this side is also 4. Okay, don't think too hard about it. When the 45, 45, 90 triangles, there's always going to be a trick. All right, I'm going to stop here and then start my next video.